Hello dear students, how are you? Hope you all are fine at your home and doing studies well. Students, today I am going to tell you about multiples and factors. There is the unit 3 multiples and factors. It's the worksheet 10 here. Yesterday we have discussed here the prime factorization method, LCM, by finding LCM by prime factorization method. Today also we are doing here the same questions, doing first prime factorization of two numbers and then finding the LCM of both the numbers. Is this clear, students? There is the question number 2, and question number 2 there is asking that finding the LCM by prime factorization method. So prime factorization method is to divide any number by prime numbers. Is this clear, students? Prime factorization method is the division of any number to the prime numbers. Let's see there is the question number A. There are the two numbers 16 and 20. We have to find what is the least common multiple between both the numbers. Least common multiple of both the numbers 16 and 20. Let's see there is this question. First we have to divide this number by smallest prime number if it can divide. Okay, students, now smallest prime number is 2. Is it divided by 2? Yes, 16 is divided by 2. 2 8 ja 16. Is this clear, students? Now again it will be divided by 2. 2 4 ja 8. Now again it will be divided by 2. 2 2 ja 4. Now again it will be divided by 2. 2 1 ja 2. Is this clear, students? Same here, doing like this. It is divided by 2. 2 1 ja 2, that is 0. Again it is divided by 2. 2 5 ja 10. Now it is not divided by 2 3 4. Now it is divided by smallest prime number, that is 5 1 ja 5. Is this clear? Yes, students. Now we have the prime factorization of both the numbers, but we have to find here the LCM. So students, we are doing here 16 is equals to 2 into 2 into 2 into 2. Is this clear? Now 20 is equals to 2 into 2 into 5. But we have to find here the LCM. So what will we get the LCM here? LCM is firstly we will check here how many prime numbers are there. That is only 2 and 5. Only two prime factors are there, 2 and 5. Now we will see that 2. Maximum number times 2 will comes here. Yes. How many times 2 comes here? There is 2 occurs as 2 times. But here is 2 occurs as 4 times. Which is the maximum? 4 times. It means we have to write here the 2 as the 4 times. Is this clear, students? Okay, students. Now we will do here the 5. 5 is maximum as occurs as 1 time only. There is no 5. There is 1 5. It means maximum number of times occurs 5 is 1 time. It means we have to write here the 5. 5 to the 10 and 2 to 4, 4 to the 8 and 8 10 to 80. This is the 80 here, which can be divided by both. This is the first multiple which is common between both the multiples of 20 and 16. If you will check by multiples of both the numbers, then you can also see that this is the least common multiple which is common between both the multiples of 16 and 20. You will check these numbers also, LCM, to find the first method, from second method. Every number you can check that multiples of 25, multiples of 35, write down there, and then list common multiples find, and then list common multiple, that one's which will be comes from this method. This is a very very easy. In that first method, multiply, taking the multiples of both the numbers. This is using the table. So you can use the multiply of any number. 35. You don't know about the 35 table. So you will write first multiplying by 2, multiplying by 3, multiplying by 4, and then you will write the table of 35. It is time consuming, so we will do these questions by this method. It is very easy method. You will understand that how to do this prime factorization. For prime factorization, you will divide from the prime factors only. 2, 3, 5. You will not divide this number by 4. You can't divide because this is not the prime number. This is divisible by 4. 4 4 is 16. We can directly take it. But we have to write here the prime factorization, prime numbers. Prime factorization. It means we have to divide only by the prime factors. Is this clear, students? So this will be divided by prime factors. It is not divided by 2, 4, 6 like this. We will divide only by 2, 5, 2, 3, 5, 7, 10, 7, 11 like this. These numbers we will divide here. Now we are taken, then after then prime factorization, we will write this prime factorization of both the numbers, and we can check here that how many numbers are there in the prime factorization, how many prime numbers are there. There are 2 prime numbers, only 2 and 5 can be used here. What is the maximum times occurs as one number? That is 2 here, and maximum number of times 5 occurs, which is written here. Maximum number of times 2 is 4 times, and maximum number of 5 is in 5, in both the factors of these different factors. Okay, students, now we will do here the part B, and in the HCF we have done here the HCF. In the HCF we have only the common factors. This is the common factor, this is the common factor. We write it as well. Is this clear, students? And after then these are 2 factors of this. This is the HCF here. But if we can find from the HCF the LCM, first write down the factors of the HCF. These are the factors. Now which are only in the 16 and only in the 20. Only in the 16 remaining factors. These are the 2 into 2 into 2. And in this 20 remaining factors. Which are the remaining factors? This is 5 only. This is 5 only. We can write all the factors which are remaining in only 60 and only 20, which are not common in both. Is this clear, students? So we can write it as multiplying this, and this becomes a 18 here. We will find by 2 methods. First, we have checked here that how many prime factors are there and what is the maximum times occurs every factor. We can write here. And if we will do from the HCF, then finding the HCF first. HCF is 1 2 common from this, 1 2 common from this, 2 are there. Now, what are the remaining factors in the 16? Remaining factors in the 16 are 2 into 2 there. And the remaining factors in the 20. In the 20 is remaining factor, that is only 5. This comes here as the HCF, and this will become the LCM here. 2 methods are there, and which I have told that by HCF you have used in the example also, and you can easily see in this example if you can understand that this method, and if you understand this maximum number of times occurs, it is written as. This is a very easy method. Now we will do here the 18 and 27 prime factorization. 18, first number it will divided by 2. 2 9 ja 18. Now it is not divided by 2. Now we will divide it by 3. 3 3 ja 9. 3 1 ja 3. This will become as the prime factorization of 18. Now we will divide it by 20. 27. It will be divided by 2. Now next number is prime number is 3. We will check from 3. Yes, it is divided by 3. 3 9 ja 27. It is also divided by 3. 3 3 ja 9. It is also divided by 3. 3 1 ja 3. Now we will find here the prime factor LCM, that is 18. First write down the prime factorization of 18. 18 prime factorization as 2 into 3 into 3. And next number is 27. Prime factorization of 27 are 3 into 3 into 3. These are the prime factors here. We can find easily the prime factorization of 18 are these. 9 to the 18 also, but 9 is not the prime factor. So we will write it as 2 into 3 into 3. These are the prime factors of by finding the way. The method of finding the prime factorization of any number, this is only the way to finding the prime factorization of any number. Now we will find here the LCM of 18 and 27. This will become as, firstly we will check here how many factors, only 2 and 3. Only 2 and 3 are the factors. 3 occurs maximum number of times. Here is only in 18, here is occurs only 2 times. And in the 27 it occurs as 3 times. It means we have to write here as 3 times. This is written as. Now we have to find the factorize as 2. It comes only 1 time, and in these factors it doesn't comes here. So we will take it as 1 times. Maximum number of times it comes here 1 time. So its product is 3 3 are 9, 9 3 are 27, 27 2 are 54. Is this clear, students? This will get the answer. Okay. Now we will do here the prime factorization of 12 and 22. Let's see here. There is the number 2 which divides 12. Yes, 2 6 are 12, 2 3 are 6, and 3 1 are 3. Now it will be divided by 2. 2 1 are 2, 2 1 are 2, and it will be divided by 11. 11 1 are 11. Now prime factorization of 12 is equals to 2 into 2 into 3, and the prime factorization of 22 is 2 into 11. Yes, students, there are the 3 factors. 2 is used here, 3 is used here, and 11 is used here. There are the 3 factors here. Firstly, we will check here 2. 2 maximum times occurs. Where? How many times? 2 times, and there is only 1 time. It means we take as 2 times first. So LCM of 12 and 22 is equals to 2 into 2. 2 times it occurs. And next prime number is 3 here. 3 occurs maximum number of times. Yes, this is only 1 time. So it is written as 1 times. Now next number is 11 here. 11 occurs as only 1 times. It means this is also the 1 times written here. Is this clear, students? Now we will take the product of these two numbers. 2 3 are 4, 4 3 are 12, and 12 11. Is the number here. Is this clear, students? This is the LCM of both the numbers. Now we will find here the LCM of these two numbers, 15 and 24. Now it will be divided by 3, not by 4. 3 5 ja 15, 5 1 ja 5. These are the prime factorization of 15 here. Now we have to find here the prime factorization of 24. It will be divided by 2. That is smallest prime factor. 2 1 ja 2, 2 2 ja 4. Now it will be also divided by 2. Then 2 6 ja 12. Now it is also divided by 2. 2 3 ja 6. Now this is not divided by 2. So it will be divided by 3. 3 1 ja 3. Now we have to find the LCM of both these numbers. Write down the prime factorization of first. 15 is equals to 3 into 5. And 24 is equals to 2 into 2 into 2 into 3. Okay, students. Now we will see here that they are using 2, 3 and 5. 5 are prime factors here. So students, you are seeing here that LCM of 15 and 24 is equals to. First we will check the 2. Maximum number of times occurs. 1, 2, 3. And there is no 2. So it occurs as 3 times. We write down it as a 3 times. Now we will check here the 3. 3 1 times. 3 1 times. It means maximum number of times is only 1 times? It means write down as the 1 times as the 3. Now check the 5. It is also 1 times used here. There is not 5 and there is the 1 times used. It means maximum number of times is. Now what will we get here? 5 2 ja 10, 3 4 ja 12, and this is 120. Is this clear, students? This will be get here the 120 as the LCM. Okay, students. Now we have to do here the prime factorization of 8 and 6. Let's see here. It is also divided by 2. 2 4 ja 8, 2 2 ja 4, 2 1 ja 2. Now again it will be divided by 2. 2 8 ja 16, 2 4 ja 8, and 2 2 ja 4, and 2 1 ja 2. Is this clear, students? Now there are the prime factors of 8. So students, there is a prime factor of 8 is equals to 2 into 2 into 2, and 16 is equals to 2 into 2 into 2 into 2. This is clear here. Now we have to find the prime factorization LCM of 8 and 16. Let's see here. LCM of 8 and 16. That must be equals to maximum number. There is only the prime factor, only 2 as the prime factor here. Now we will see here that maximum number of times 2 occurs in every factor, every number. In this number, factors of this number have 2 as the 4 times occurs, and in this 8 the prime factor 2 occurs as only 3 times. It means maximum number of times of 2 is, yes, that is 4. 4 times it is used here. It means we have to use in the 4 times as the LCM also. So this will be equals to, that is 16 here. 2 2 ja 4, 4 2 ja 8 2 ja 16. This is the answer is 16 here. LCM of 8 and 16 is 16. Is this clear, students? Now we will go to the next question. First, it will not divided by 2. No. 3. No. 4. We will not check from 4 because it's not the prime factor. Now we will check from the 5 here. This is divided by 5. Yes, it will write here. 5 5 is 25 and 5 is 5. We will get here this. So students, prime factors of these are this, and prime factors of 35 are 3 not divided by 3, not divided by 2, and the next number is 5. Yes, it will be divided by 5. And then 5 is the prime factor of this. 5 7 ja 35 and 7 1 ja 7. Is this clear, students? Now write down the prime factors of 25 is equals to 5 into 5, and prime factors of 35 as 5 into 7. Now LCM of 25 and 35. This is equals to, first there are the two factors here, 5 and 7 only. Check the 5 as how many times it occurs there. This is 2 times occurs and this is 1 times occurs. It means maximum number of times occurs 2 times. It means write it as 2 times here. 5 into 5. Is this clear, students? Now there is the next factor is 7 here. 7, how many times occurs it? Yes, that is 1 times only. There is no 7. It means maximum number of times occurs is 1 time. So write it as there 7. Now this product is 5 5 ja 25 and 25 7 ja 175. Is this clear, students? This will get the LCM here. These are the prime factorization of any number which are doing first the prime factorization of both the numbers, then write down the prime factors, and then taking LCM by finding the maximum number of that factor occurs here. Is this clear, students? Maximum number of times the factor occurs is written in the LCM, and then finding the product of these factors, and this will be the LCM of these numbers. Is this clear, students? I hope you have understood these prime factorization. Very easy methods are there. And now you have here 25 and 35. 5 questions are, let's see there. Now students, there is the two numbers. Some more questions are there in this question. Let's divide it by 2. 2 1 ja 2, 2 8 ja 16. It will again divided by 2. 2 9 ja 18. Now it will be divided by 3. 3 3 ja 9. 3 1 ja 3. These are the prime factorization of 36. First, it will be divided by 2. Again, it will be divided by 2. Let's check the last digit only. And now it will be divided by 2. Now this is not divided by 2. Now check from 3. Yes, it is divided by 3. 3 3 ja 9. And it will again divided by 3. 3 1 ja 3. Until we get the 1 here. Now it will be divided by 2. No, because last digit is 5 here. Now it will be divided by 3. Yes, 3 1 ja 3. 3 5 ja 15. 3 5 ja 15. And now it will be divided by 5. 5 1 ja 5. These are the prime factorization of 45. Now check here this. It is divided by 2? No, it is divided by 3. 3 1 ja 3. 3 1 ja 3. Now it will be divided by 11 1 ja 11. Now let's check this question. It will be divided by 2. It will not be divided. We will not divide it by 4 because 4 is the non-prime factor. So it will be divided by 2 and 2. 2 2 ja 4. 2 2 ja 4. Again it will be divided by 2. 2 1 ja 2. 2 1 ja 2. Now it will be divided by 11. 11 1 ja 11. Now we will divide it by 2 here. Sorry. Let's check. First we have to find the LCM. So its factors are 36 factors are 2 into 2 into 3 into 3. Is this clear? Now 45 is equals to 3 into 3 into 5. Is this clear, students? So LCM of 36 and 45 is equals to, what will be the LCM? First check the prime factors 2, 3 and 5. Only 2, 3 and 5 are used here. First check 2. Maximum number of time 2 occurs. There is only 2 times and there is no 2 here. Then maximum number of times 2 times occurs. It means write down the 2 as the 2 times. Is it clear? Now check 3. There is also the 2 times. There is 3 also the 2 times. So there is maximum number of times 2 times occurs. So write down here the 2 times as the 3. Is this clear? Now there is the factor 5. Factor 5 is used here only one time and there is no 5. It means maximum number of times occurs 5 as one time. That is equals to 5. Is this clear? Only one time we will take here. Now what will be the product here? 5 to the 10, 3 to the 9, 9 to the 18, 18 that is 180 is the LCM here. Is this clear, students? Now we will go to this part. Check the prime factorization first and then finding the LCM. Let's see there. 33 is equals to 3 into 11. Now 44 is equals to 2 into 2 into 11. Now we will check here that how many times the factors occurs. So LCM of 33 and 44 is equals to, first there are 2, 3 and 11 are the factors. First 2, 3 and 11. First we will check the 2. There is no 2 and there is 2 times as 2. Then maximum number of times 2 occurs 2 times. It means in the LCM also maximum number of times 2 occurs as 2 times. And next number is 3. 3 is not there. And there is 3 one times as the 3 here. It means maximum number of times 3 occurs only one time. It means this is written as 3 here only one time. Now there is 11, there is 11. But it is also used here the one times only. And there is also one times used as 11 here. So it will be written one times as the 11 in the LCM. So what will we get here? 2 to the 4, 3 to 12 and 12, 11 the 12 132 as the LCM of these two numbers. Is this clear, students? Now we will go to the question I. There is the first prime factor, yes, 2. It is divided by 2. 2 1 by 2 and that's a 0. And 2 5 ja 10. Now it will be divided by 5. 5 1 ja 5. You will do yourself all these questions after understanding previous questions. And then you can check your questions as from this. Is this clear, students? Now it will be divided by 3, 2, no, 5, yes. It will be divided by 5. 5 7 ja 35 and it will be divided by 7. 7 1 ja 7. So factors of 20 are 2 into 2 into 5 and factors of 35 are 5 into 7. And LCM of 20 and 35 is equals to 20 and 35. What will be the LCM here? First, there are prime factors 2, 5 and 7 is used. 2, 5 and 7. Only 3 factors are used there. First we will check 2. 2 is here, 2 times occurs. But here is no 2. It means maximum number of times 2 occurs there, 2 times. Write it in the LCM as the 2 times here. Is this clear, students? Now there is the factor 5 and 5 is used here only 1 time and there is also used as 1 time. So 5 is taken as 1 times only in the LCM of these two numbers. Now we will have the 7 as the prime factor and 7 prime factor is used as only 1 time and there is no 7. It means maximum number of times 7 occurs there 1 times only. It means we write it as 1 times. This one we get here 5 2 ja 10 and 2 7 ja 14. 140 is there to multiply. After multiplying it, is this clear? Now we will have the question number 2 2 ja 4, 2 7 ja 14, 3 9 ja 27 and 3 3 ja 9 and 3 1 ja 3. Now again it will be divided by 2, 2 1 ja 2, 2 9 ja 18 and 19 is the prime number, so it will be divided by 1 and itself. 19 1 ja 19. So write the prime factors of 54. 2 into 3 into 3 into 3. Now there is a number 38. 2 into 19 and what will be the LCM of 54 and 38. So students, let's see there are the prime factors 2, 3 and 19 here. Only 2, 3 and 19. So first check the number 2. How many times 2 occurs as? In the both the numbers there is only 1 time and there is also 1 times occurs. It means there is the number in the LCM written as 2 as the only 1 times. And now we will check the number 3 here. 3 occurs here 3 times in the first number and there is not 3. It means there is the 3 has 3 times. It means maximum number of times 3 occurs as in this number. It means we have to write in the LCM also as 3 times. There is the 3 here. So 3 into 3 into 3. And now there is the number 19. 19 occurs only 1 time and in this number there is no 19. So 19 also will be taken as 1 time. Now multiplying all the numbers we will get here. So students, it's multiplying at 2 3 ja 6, 6 3 ja 18, 18 3 ja 54 and 54 is multiplying by 19. 54 is multiplying by 19. We will get here the 1026 as the LCM of these two numbers. So students, there is the LCM is 1026 and these are the questions here of prime factorization. LCM, finding LCM by prime factorization method. I hope so you have cleared this method after doing all these questions. There are so many questions we have done here, so its method is clear. Okay students, do revise this exercise and do revise this chapter. Now we will do here the brain teachers exercise. Let's do. So students, there is the brain teachers exercise. In the brain teachers exercise, there is the question number 1. and in the question number 1 there are the optional questions. So we will do here. For in the first question, not a factor of 48. 48, not a factor of 48. Let's try to find the first factors of 48. Factors of 48 are 2 to the 4, 2 4 the 8, 2 1 the 2, 2 2 the 4, 2 6 the 12, and 2 3 the 6, and 3 1 the 3. So 2 2 2 2 3. These are the factors of 48. So not a factor of 48. 7 doesn't divides the 48. 6 divides the 48 exactly. 6 8 the 48. 12 divides exactly the 48. It means 12 is the factor. And 48 is also divides this factor. 48 is the factor. But 7 is not the factor of 48. It means answer is, because 7 doesn't divide it. 7 6 are 42 and plus 6 remainder. There is remainder not 0. It means there is a remainder other than 0. So it will not be the factor of 48. So its answer is 2. Now which number is the prime number? Prime number, yes. It means prime number only have exactly 2 factors. Only 1 and the number itself. This will have the number 1 and 91 are the factors of this number. But other than this, also the factors of this, that are the 13 and 7. 13 and 7. 13 7 are 91. It means 13 also divided this factor. Exactly 2 factors we have here for the prime factor, prime number. So it will not be the prime number. And this number? No, because 3 and 19 are the factors. 3 and 19 are the factors of this number. So it also not be the prime number. 1 and itself, except 1 and 57, there is the another factor, that is 3 and 19. So it will not be the prime number. Now we will check the 97. 97 is not divided by any number other than 1 and 97. So it will be the prime factor. Now we will check the 81. Yes, it will be divided by 3, 9, 27. It means it is not the prime number. It is also not prime number. Then prime number is only 97 is here. Now we will do here the LCM of 10, 20 and 25. LCM of 10, 20 and 25. Find the factorization of 10. Factors of 10 are 2 into 5. Factors of 20 are 2 into 2 into 5. You will find the prime factorization of 20 like this. 10, 20 and 25. You will find these factors 2 into 5, 2 into 2 into 5, and for 25, 5 into 5 is the prime factorization of 25. Now we will get here the LCM of these 3 numbers. LCM means there is the number 2 and 5 only, and 2 and 5 maximum number of times who occurs. Maximum number of times 2. There is 1 times, there is 2 times, and there is no times. It means maximum number of times 2 occurs as 2 times. It means in the LCM there is 2 into 2. Now there is a 5 number. There is 1 times, there is 1 times, and there is 2 times 5. It means maximum number of times 2 times. So we have to write in the LCM also 5 into 5. Now we multiply 5 to the 10, 5 to the 10, and 10 into 10, 100. So its LCM is 100 here. We can easily find this 100. Is this clear, student? So its LCM is as 100. You will do this yourself. So its LCM is 100. You will do yourself. Find prime factorization of 10. Find prime factorization of 20. Find prime factorization of 25. Then you will check then you will write prime factorization of 10, factorization of 20, factorization of 25. And you will find maximum number of times which occurs. Only 2 and 5 are the factors here. 2, maximum number of times 2 occurs, and maximum number of 5 occurs. Both are written in the LCM, and then you will multiply the all numbers in the LCM. Then you will get here the LCM as 100. Is this clear, students? Now we will do here the part B, the prime factorization of 36. first suppose that there is a prime factor. This is possible prime factorization because there is a 4. This is not the prime number. It means this is not the prime factorization. This is not possible. Now we will check this. There is 9, not the prime factorization. There is 12. This is not the prime number, so it will not be possible. So what is the possibility here? Only this. That is the part 4. Is this clear, students? Now we will do here the part E. In the part E, 48 has how many factors? 48 we have done here. 48 has how many factors? 1, 2, 3, 4, 5. 48 has one. Sorry, it's not. So students, you are seeing here the 48 has factors. How many factors of 48 there? 48 has factors as 1 is a factor of 48, 2 is a factor of 48, 3 is a factor of 48, 4 is a factor of 48, and 5 not factor, 6 is a factor of 48, 6, 8 is a 48. It means process is stopped there. 8 6 and 6 8 48. It means process is stopped there. Now the quotient get from 4. What will we get here? 12. This will be the factor. Now quotient obtained from 3. After 3 there is 16. And after quotient getting from 2, 24. And the last one is quotient getting from 1. That is 48. How many factors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many factors are there? That is 10. This is the first answer is there. Is this clear, students? Now we will go to the next part. Write first 4 multiples of all the numbers. First 4 multiples you know as well. 7. Multiples means table. So you write the only 4 multiples. 7, 14, 21 and 22. Bas. Up to this. Now 9. Now this is 1 here. 1 1 ja 1, 1 2 ja 2, 1 3 ja 3, 1 4 ja 4. These are the factors, multiples of these 4 multiples of these numbers. Is this clear, students? Write down these questions and now we will do the next questions here. In the question number 3, students, there are the fill in the blanks here. In the first part A, there is the part A. In part A, 2 into 3 into 7. 2 into 3 into 7 is equals to, there is, now students, there is the part 1. In the part 1, 2 into 3 into 7 is equals to 42. So, 42 is multiple of which numbers? 2, 3, 7. It means answer is 2, 3 and 7. This will be the answer here. Now, we will go to the part B. In the part B, fifth multiple of 9. Fifth multiple of 9. Fifth multiple of 9 is 9 5 ja 45. Is this clear, students? This will be the fifth multiple of 9. It's the answer here. Now we will be the part C is 48 multiple of 6. 48 is a multiple of 6. Is 48 possible in table of 6? Yes. So 6 8 ja 48. It means if the 8th multiple of 6 is 48. So yes. Part D is there. List multiple of 65. List multiple of 65 is itself 65. Because if we write the multiples of 65, then 65 and then 65 2 ja, then 65 3 ja, then 65 4 ja. It means the first is the list here. List is the 65 itself. Now part E. Part E is there. In part E, 7 into 3 is equal to 21. So 7 and 3 are the factors of 21. 7 and 3, 7 into 3 is equals to 21. It means 7 and 3 are factors of 21. 7 and 3 are factors of 21. These are the factors of 21. Because prime factorization of 21 is 7 into 3. Prime factorization of 21 is 7 into 3. It means 7 and 3 are the factors of 21. Confirm. Is this clear? Now we will go to the part F. F is, the F part is 8 a factor of 70. Is 8 a factor of 70. It means if it is the factor of 70, it will divide it exactly. Let's see there. 70 is divided by 8. Because we have to check that 8 is factor or not. If this is factor of this, it means remainder is 0. Yes, check. 8 8 is 64. There is remainder is 6 there. Now it will not divide, but remainder is 6. So it will not be the factor of this. So no. Is this clear, students? Now G part. Part G is 1 a prime number? No, because we have done already that 1 has only one factor, so it is not the prime number and it is also the not composite number. Is this clear, students? So no. Okay, students, these are the questions here which we have done here. Now you will do question number 4 here. Let's see there. So students, here is asking that factors of 27, 90, 38 and 40. So we have to find here the factors of 27. Factors of 27 are adject divided by 1. Yes, adject divided by 1 because 1 is the factor of every number. Adject divided by 2. No. Adject divided by 3. Yes, 3 9 is 27. There is the 3. Remainder is 0 after dividing by 3. There is the number 4. 5, 6, 7, 8, 9. Yes, 9 is divided. 3 9 are 27 and 9 3s are 27. It means stops there. And if the previous factor is 1, so its the last factor is 48. After dividing by 2, you get the quotient as 48. It means these are the factors of 27. Is this clear, students? Now we will go to the part 90. In the 90, 1 is the factor of this, 2 is the factor of this, yes, 3 is the factor of this, yes, 4 is the factor of this, no, 5 is the factor of this, yes, 6 is the factor of this, yes, 7 is the factor of this, no, 8, no, 9 is the factor of this, yes, and 10 is the factor of this. But after dividing by 9, the quotient is 10 and 10. After dividing by 10, quotient is 9. So the process stops, remains the here. And now the quotients get from these numbers, we write it here. Is this clear? Quotient gets from 6. After dividing by 6, it will get here 15. 15, 6 is 90. We will get here the divide 90 by 6. 90 divided by 6. 6 1 is 6. 3 is there. 6 5 is 30. So we will get here the number 5. 15. Is this clear, students? Now there is the 15 number, quotient of 6. Now quotient of 5. Quotient of 5. After dividing by 5, if we divide it by 5, there is 18 number. Is this clear, students? Now after dividing by 3, we will have the quotient as after dividing by 3, 30. This is the 30 number. Now divided by 2, it will get the quotient as 45. And now it will be divided by 1. There is the, after dividing by 1, this will get here 9. So 90 is the factor of this number. Is this clear, students? So now we will check the factors of 38. 1 divides it, 2 divides it, and 3, no, 4, no, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, 19 divides it, and 2 9 ja and 19 2 ja. It means stops this process. And now quotient from 41, that is 38 is there. Is this clear? These are the factors of this number, that is 38. Now we will divide this number. We will divide the 40. So the factors of 40 factors of 40 are 1, 2, 3, 4, 5, 6, 7, 8, yes, 5, 8 is 40 and 8, 5 is 40. The stops process. Now you will add on the tips. If you have done already these exercise, that worksheets in which we have done these factors, you should remember these factors also. Okay, students. So doing this, first you will do these worksheets and then those worksheets, and now after those worksheets have been done on the tips, then you will solve these questions easily. These are the factors which we will divide as like this, and then we get these factors. So you have to know about the factors of these, know about the dividends of these, know about what is the quotient here after dividing by 6. So you will solve easily. So it's a request to all students, first solve again and again at least 3 times the worksheets of factors and multiples. That is worksheet 6, worksheet 6, 5 and 6. 5 and 6 worksheet and 10 worksheet. Worksheet 10, 5 and 6 and worksheet 10. You will solve again and again at least 3 times. Then you will solve all these questions very easy. Is this clear, students? Now we will go to the next. After dividing by 4, it will get here the 10 as the factor, and after dividing by 2, it will get the factor as 20 and 1 as the quotient is 40 here. Is this clear, students? These are the factors of 40. Now there is a quotient here, 5 is 217. 217 is divisible by 27. Is divisible by 27. Is this clear, students? So we will see here that it will be divided by prime factors of this number. It will be divided by prime factors of this number. So 27, we will divide it by 27, 217. We will get here the number as 1. So it will not be divisible by 27. So no. Is this clear, students? If this is divisible, it means there is a remainder 0 here. Okay, students. Now we will go to the next question. That is question number 6. In the question number 6, you have to find the prime factorization of the following numbers by factor 3 method. So let's see there. Now students, there is a question number 6. In the question number 6, there are the prime factors. First, it will be divided by 2. Yes, 2. After dividing by 2 to the 30, we will get the quotient as 15. So we will write it as 15. But this is not the prime. So we'll again divide it. It is divided by 2? No. It is divided by 3. Yes. 3, 5 is 15. It means this is the prime factor. So stops this process. 2, 3 and 5. 2 into 3 into 5. So prime factorization of 30 is 2, 3, 5. Is this clear, students? Now we will go to the 84. It will be divided by 2. Yes. And quotient is after dividing by 2, 2 4 ja 8, 2 2 ja 4. Now it will be again divided by 2. Yes. And it gets the factor as 2 to the 4, 2 1 ja 2. Now it will be divided by 2. No, it will be divided by 3. Yes, there is 3, and we will get here the 7. Is this clear? These are the prime numbers. So stop this process. Prime factorization 2, 2, 3, 7. So its prime factorization is 2 into 2 into 3 into 7. We will get the prime factorization of these numbers. Okay, students. Now we will go to the question number 7. In the question number 7, we have to find the prime factorization by the division method. So it's the division method. So divide it by 2. This is the 2 here. It will be divided by 2. Smallest prime number. 2 1 ja 2. 2 8 ja 16. 2 9 ja 18. 3 1 ja 3 3 ja 9. And 3 1 ja 3. So students, what are the prime factors? 2 2 3 3. 2 into 2 into 3 into 3. These are the prime factors of 36. Now we have to find the prime factors of 74. So there is 2, 2 3 is 6, 2 7 is 34, and 37 is the prime number. So it will be divided by only 37. So 2 into 37, it will be written as the prime factorization of 74. Now in the question number 8, we have to find here the LCM. In the question number 8, we have to find here the LCM. So first we will write here the prime factorization and then LCM. Is this clear, students? Now there is the number 2, 2 1 ja 2, 2 4 ja 8, and 2 7 ja 40, and 7 1 ja 7. These are the prime factors. Now we will do here 2 2 ja 4, 2 1 ja 2, and 3 7 ja 21, and 7 1 ja 7. And it is also divided by 2, 2 5 ja 10, and 5 1 ja 5. These are the prime factors. And this is divided by 3. No, 5, yes. 5 1 ja 5, 5 9 ja 45, and it will be divided by 19. These are the prime factors of these numbers. Now we will write here the prime factorization of these numbers is 28 is equals to 2 into 2 into 7, and 42 is equals to 2 into 3 into 7. Okay, students. Now we have to find here the LCM. LCM of 28 and 42, that equals to. First, we will check 2, 3, 7 as the prime numbers here. Only 2, 3 and 7 used here. First, we will find here that 2. How many times occurs? There is 2 times and there is 1 times. Maximum number of times? Only 2 times. So, it will be written as 2 times here. Now, the factor is 3. Factor is 3, not there, and there is used only 1 time. It means maximum number of times at least 1. It means we will write it as 1 times. Now there is a 7, 1 times and 1 times. Maximum number of times used 1 times. It means this will be written as 1 times here. Is this clear? Times is we have to count here. How many times is it written here? How many times is this number written here? And that number is written in this LCM here. Now this is the LCM here. Multiplying 2 to the 4 3 is 12. 4 3 is 12 and 12 7 is 84. Is this clear, students? Now we will go to the next. Prime factors of 10 are 2 into 5. Prime factors of 95 are 5 into 90. And the LCM of 10 and 95 is equals to. First we will check the list number, that is 2 here, and 2 is used 1 times only. It means we have to write as 1 times. Now there is the number next 5 here. 5 is 1 times here, 1 times here. It means maximum number of times 5 used only 1 times. It means there is 1 times 5. And now there is the 19 times 19. There is not 19 here, and there is a 19 here. And here is 19 used as only 1 times. It means maximum number of times 19 is used here. This. Now 5 is a 10 and 10 19 is a 90. 190. This will be get here the answer. Is this clear, students? In this question, we will do here the LCM, and in these questions, we have to find here the only prime factorization. Is this clear, students? Okay. Now we will go to the next question. Write down these questions and solve this. Now students, there is the question number 9. In the question number 9, we have to write down here the even numbers between 20 and 15 and even numbers which are divided by 2. Between 20 and 50, so 20 is not counted here. That next number is 21. Is it an even number 21? No, because it is not divided by 2. So next number is 22. There is 21? No. 22 is there. 23? No. 24? Yes, it is divided by 2. 25? Not divided by 2. 26 is divided by 2. 27? No. 28 is divided by 2. 29? No. 30? Yes, it is divided by 2. 31? No. 32. 33? No. 34. 35? No. 36. 37? No. 38. 30, 40, 39? No. 40. Yes. 41? No. 42. It will be divided by 2. One number missed there and then this is divided by 2. That is 43, no. 44. 45, no. 46. 47, it is not divided by 2. 48 divided by 2. Yes. 49, not divided by 2. 50 divided, but we have to write here between 20 and 50. So we will not count here the 20 and 50 here. Is this clear, students? Now we will go to the next question. Prime numbers between 50 and 80. Yes. 50 and 80. We have to write here 51, 52, 53, 54. It will be divided by, write down only 51. Is it divided by any number? Yes, 3. It will not be the prime number. 52, it will be divided by even number. Even number never can be the prime number. Even number, because it is divided by 2. It is divided by 2 and we will get here the at least one factor as other than 100 itself. Except 2. Except 2. No any even number is the prime number except 2. 2 will be the prime number, but after that no even number is the prime number. So 52 is the even number, so it will not be the prime number. Now 53, yes. So students, there is a prime number 53, yes. 54 even number, not the prime number. 55 is divided by 5 and 11. 5 and 11, so it will not be. And 56, no, because it is even number. 57, 3 divided by 3 and 90. So it will not be the prime number. And after this, 58, even number. 59, this will be divided by any number? No. It means this is the prime number here. Is this clear, students? Now, any number divides 60. Yes, 60 is the even number. So it will not be the 61. 61. It is not divided by any number. So it is the here 61. 62. Even number. 63. 63, 7 and 9 are the factors of this. So it will not be possible. 64, not possible even number. 65, not possible divided by 5. Last digit is 5. 66, divided by 2. It will not be possible because this is the even number. 67, yes. This is the prime number which is not divided by any number. 67. 68, even number, not possible. 69. 69 divided by 3, not possible. 70, even number, not possible because it is divided by 2. 71, yes, this is the number. 71, 72, no, even number. 73, yes, it may be the possible number. 74, no. 75, no, 5 divided by 5. 76, it is even number. 77 divided by 7 and 11. 78, it is divided by 2. For 79, yes, it may be possible. It is possible here. And 80, between 50 to 80 we have to find here. So we will not count here the 50 and 80. So students, you are seeing there are the even numbers which are between 50 and 80. Is this clear, students? Now we will go to the question 11. In the question 11, 5 odd multiples of 3. Odd multiples only. 3 odd multiple? Yes. 3 2 is 6. 6 is odd? No, it is even number. 3 3 is 9. It is the odd number. 3 4 is 12. It is the even number. 3 5 is 15. 3 6 is 18. It is not. It is even number, not odd. And 3 7 is 21. 3 8 is 24. It will not be possible because it is even. 5. Next is 3 7 is 27. These are the 5 multiples of 3 which are odd here, not even. Even are cut here. Is this clear, students? These are the first odd multiples of 3. So students, your syllabus is completed here, and do revise and solve all the questions again and again. Then you can easily solve in the exam. Okay students, so have a nice day. Bye students. Okay.